Okay, welcome to data section 9.1. We'll be looking at the coordinate plane as well as graphs of equations and circles. So this section is very geometric in nature, and we'll be looking at a lot of geometric concepts during this section. Okay, so just to kind of orient you to the Cartesian plane or the coordinate plane, you have your origin here in the center, and that's the point 0, 0. And you have your different quadrants that you need to be familiar with. So your quadrants go counterclockwise. They start here in the upper right and they go around. This is quadrant 1, 3, and quadrant 4. And the ones that actually fall on the coordinate axes, those are not going to be considered part of any quadrant. And just remember, when you give an ordered pair like the ordered pair 2, 3, the first coordinate is your x coordinate, which tells you how far you need to move left or right on the x-axis. This is your x-axis, and this is the y-axis here. And so to plot the point 2, 3, we would go to the right 2 places and up 3 places, and we'd find that our point would be here on the coordinate plane. Okay, so when we're labeling on the coordinate plane, each point basically gets like its own address, and that address is its coordinates, and they are of the form x, y, like we said. So if we're going to go in the negative direction, then we'll go back 2 and up 2 to get to this point. So the coordinates would be negative 2, 2, and so forth. Okay, the first formula, the geometric formula that I want to look at is the distance formula and then the midpoint formula. So the first one would be the distance formula. So if we're trying to find the distance between any 2 points, we're going to have to label the first point as x1 and y1, and the second point is going to be x sub 2 and y sub 2. So whichever is your first, it really doesn't matter the order of these as long as we're consistent. So this one's going to be x sub 1, y sub 1, and x sub 2, y sub 2. So when I go to plug it into this distance formula here, the distance formula is actually a derivation of the Pythagorean theorem. So that's kind of where it comes from. I'm not going to go through all the background of that. But my distance here, when I go to calculate this, you've got x2. So my x2 is going to be this negative 4. And so we're going to subtract from that x sub 1. And then we're going to square it. And then we're going to have y sub 2. So y sub 2 is going to be 6. We're going to subtract from that y sub 1, which is 5, and square that. So then we'll simplify it. So this is going to be negative 5 squared plus 1 squared. It's going to give us the square root of 25 plus 1, or the square root of 26. Now, on most of these, especially if it says give an exact answer, it wants it left like this and not as a decimal approximation. So this is how I'd want your answer submitted unless it's specified for a number of decimal places. If you could simplify this radical, then you would need to do that. Okay, here's a problem that is applying the distance formula. So we want to know which point is closer to this particular point. So we need to find the distance from P to A. And then we also need to find the distance from Q to A. Okay, so if we look at this, we are going to let our P be our first point. And we're going to label this point as our x sub 1 and our y sub 1. And then we're going to let the A be our second point. And so it'll be our x sub 2 and our y sub 2. So for the distance between these, we're going to do x2 minus x1 squared plus y2 minus y1 squared. This would be 4 squared, and this is going to be 3 plus 2. 2 negatives make a plus, so that's going to be 5 squared. We'll have the square root of 16 plus 25, and that's going to give me the square root of 41, which cannot be simplified. Okay, next we're going to be looking at the distance from Q to A. So we're going to let Q be our first point. So that would be our x1 and our y1. And then our A is going to be our next point. So that's going to be 5, 3. So this will be our x sub 2 and y sub 2. So to find the distance here, using the same formula, I'm going to do x2 minus x1 squared plus y2 minus y1 squared. So I'll go through and simplify. This is going to be a negative 3 squared, and this is going to be a negative 6 squared. So I'm going to have the square root of 9 plus 36 is going to give me the square root of 45, which if I were to go ahead and simplify this, this is actually going to simplify to be 3 on the square root of 5. Okay, so we want to know which one is closer to this point. Is P closer to A or is Q closer to A? So when I compare these values here, okay, these are my two distance. It's a little bit hard to compare, so I'm actually going to go back to this one for comparison purposes. So the square root of 41 is going to be less than the square root of 45. And so because it's less than, then that means the P is going to be my closer point. Okay, so P is closer to A than Q is. And this is just a sketch of the coordinate plane with these points plotted. And you can kind of see the distance here that P is actually a little closer to A than Q is. Okay, the midpoint formula is another geometric formula that we work a lot with. The midpoint formula is literally just the middle of the line segment, the midpoint of that line segment. And we find that by adding the x's up and dividing by 2 and adding the x's up and dividing by 2 and then adding the y's up and dividing by 2. So where the distance formula is a single number, the midpoint formula is an ordered pair with an x and a y. So here, if this was my x1 and y1, and this is my x2 and y sub 2, then my midpoint is going to be add the x's up, so 2 plus negative 4 over 2, and then add the y's, 9 plus 7 over 2. Go ahead and simplify that. So this is going to be negative 2 over 2. This will be 16 over 2. So I'm going to have negative 1 and 8. Okay, this one is an application of the midpoint formula. So here it says show that a quadrilateral with the given vertices is a parallelogram by proving that its two diagonals bisect each other. And we do have a helpful hint here, and that is that two diagonals, if they have the same midpoint, then they must bisect each other. So the first thing I would suggest doing is plotting these points. So if we have the point 1, 2, it's going to go here. So this is P. And then we're going to have the point 4, 4. So this is Q. And then we're going to have the point 5, 9. So this is R. And then the point 2, 7 is going to be here, and that's going to be S. So if we connect those with as straight a lines as possible, then hopefully you see that this would be a parallelogram, but we need to prove that algebraically or geometrically by showing that the midpoint of each of the diagonals is the same. So we need to find the midpoint of the line SQ, and then we need to find the midpoint of the line RP. Okay, so the midpoint S's coordinates were 2, 7, and Q's was 4, 4. So the midpoint of that would be add the x's, divide by 2, and add the y's, and divide by 2. So we get the point, this will be 6 over 2, which is 3. This will be 11 over 2. Okay, here if we do the same thing with the other diagonal, the diagonal RP, then we're going to have the coordinates of R is 5, 9, and P is 1, 2. So if I add my x's together, I'm going to get 6 over 2. If I add the y's together, I'm going to get 11 over 2. And this is going to simplify to be 3 and 11 halves. So because these two are equal to each other, we therefore have shown that they bisect each other, and therefore it is a parallelogram. Okay, and this is a little bit better sketch as far as what we're looking at geometrically. Okay, so when we talk about graphing different equations, one thing I want to show you today is how to use your calculator to complete some of these graphs that you may have to do. So if you don't have your calculator out, go ahead and get that out. And we're going to work with the tables. Hopefully you're familiar with those, but if not, I'll do a brief introduction here. Okay, this is the equation that we're going to be working with. Anytime that you enter something in your calculator, you have to have it solved for y. So I'm going to solve this for y, which means I'll have negative y equals negative 2x plus 3. I'm going to divide by the negative 1, and I'm going to get y equals 2x minus 3. So this is my equation that I'm going to put in y1 in the calculator, and then I'm going to get some of these points on the calculator. Okay, so in order to graph this on your calculator, if you have your calculator turned on, we're going to go up here to the y equals button, and you're going to enter in the equation that we just solved for. So 2, here's the x key, and then minus 3. Okay, we want to create a table to use to fill in, because some of the WebAssign problems will ask you to fill in tables. So if you see where it says table here, we're going to go to second and graph, and it brings up a table for you. So if you need to complete some of the values on a table, these are going to be here. If you need to adjust your table in any way, this table set is where you're going to go and do that. So you'll do second and table set. So it gives you a couple options. This table start just says basically where's your table centered at. So if you want it centered at 0, which is usually where we're going to start, then you start it at 0. And this delta table means how do you want your table to change? And generally by ones is fine. So if you're going to find like x equals 0, x equals 1, x equals 2, and so forth, then you should be able to just have it set on 1 there. So looking at the table for this one, then you can fill in these values. And if we want to actually graph this, I'm going to go to Zoom. And we're going to use mostly in this class Zoom Standard. So if you'll choose 6, your calculator may take a few minutes to think, but then here's that graph that we were looking at here. A couple neat things you can do, if you press trace, then and you need a value off of your line, once you have the trace key pressed, if you want to press 2 and enter, it's going to give you the value of this line at 2. So that's another way you can fill in your table. So if I want it at 6, then it's going to tell me it's 9. One thing to watch for though, if I put something that's not on the graph, it's going to give you an error message. So you might have to change your window a bit to do that. And we're going to talk more about changing windows later, but your window, if you go up here to your window, you can adjust your window values. X min is like how far to the left. X max would be to the right. I usually don't mess with the X scale too much. Y minimum is to the bottom, and Y maximum is to the top. So you can adjust on those a little bit as well. So that's just a quick orientation to our graphing calculator. We'll definitely be working more with that as we go. Okay, so we could have gotten these values off the calculator table, and then from there you want to just make these into an ordered pair. So you'd have like -1, -5 would be your ordered pair. Combine these two together and you get 0, -3, and so forth. Okay, and this is the graph. If you were to go through and plot each one of those points that we just came up with, then they're going to line up in that straight line. Okay, moving on to finding intercepts. Intercepts is a very important concept, especially when we start graphing different types of functions. So the x-coordinates of the points where a graph intersects the x-axis is referred to as its x-intercepts. And we find the x-intercepts by setting y equal to 0. So it's almost like opposites. X-intercepts, you use the y equals 0. And then when you get down here to the y-intercepts, which is where it touches the y-axis, you're going to actually set x equal to 0 in your equation. So here's kind of a graphic. The definition is the same as we just talked about. X-intercepts are so very important. They have lots of different names. The first name is, sometimes they're called roots, solutions, zeros, but for any of these or the x-intercepts, you're going to set y equal to 0 and solve it for the x. So what we're finding is we're finding these coordinates where it touches the graph, where the graph touches the x-axis, excuse me. Okay, the y-intercepts is where it touches the y-axis, and we find those by letting x equals 0 and then solving it for y. We don't have as many other names for y-intercepts just because they're not quite as important to the equations. Okay, so here's a couple examples that we want to go through in finding these. We want to find the x and the y-intercepts for this graph. So the first thing we want to do, if we're going to find our x-intercept, we're going to let y equal 0 or substitute y equals 0 into that. So that's going to be 0 in the place of y. And then we want to solve this for x. Okay, so if I'm solving this for x, I'm going to have x squared equals, move the 2 over, and then take the square root of both sides. And so I'm going to get plus or minus the square root of 2. So my coordinates for the x-intercepts are plus or minus the square root of 2 and then 0. As far as remembering which order, if this is an x, it goes in the first slot here. And we already said y is 0, so that's going to go in for the y on that. If we look over here and find the y-intercept, our procedure for that is to let x equal 0. Okay, so to do that, we're going to have y equals 0 squared minus 2. So we're going to get y equals negative 2. So the coordinates then is going to be x is 0, y is negative 2. So this particular graph had 2 x-intercepts and only 1 y-intercept. Here's a sketch of the graph, and you can see that it crosses the x-axis in 2 places, crosses the y-axis in 1 place. So 2 x-intercepts, 1 y-intercept. Okay, here's a couple for you to practice with. We've actually just done the first one, so go ahead and start with the second one here. If we look at this, if you want to try it, go ahead and pause it and try it. If not, then just kind of listen as we go with this. You've got, if we're going to start with the x-intercept, we're going to substitute y 0 in for y. So we'll have 4x squared plus 25 times 0 squared equals 100. We know that 0 times anything is just 0, so that term is gone. We'll divide by 4, and we'll get x squared equals 25. So we'll take the square root of both sides, and so x is going to be plus or minus 5. So our coordinates are plus or minus 5, comma 0. So that would be my x-intercept. The y-intercept here, we're going to let x equal 0. So we'll have 4 times 0 squared plus 25y squared equals 100. This term goes away, and you've got 25y squared equals 100. Divide by 25. We'll get y squared is 4. So we'll take the square root of both sides, and we'll get y equals plus or minus 2. So our coordinates are 0, plus or minus 2. So this particular one had 2 x-intercepts and 2 y-intercepts because for those of you that may have worked with other geometric figures, this would actually be an ellipse. So an ellipse is going to have two x-intercepts and 2 y-intercepts with that. You may have worked with it where whichever one you're putting in for 0, you hold your finger over that particular term, because if you're putting 0 in for it, it's going to wipe that term out. So that's one kind of strategy, is just to eliminate that particular term. It's kind of hard for me to show you here on the screen like this, but basically whenever you put in 0 for it, that term goes away and you're left with the other part. Okay, here's another one to check for x-intercept. and y-intercepts. X-intercept, we've already said you let y equal 0. I like to go ahead and write this out because it helps keep me organized with each step that I'm doing. So here I'm going to have x squared minus x times 0 plus 3 times 0 equals 1. So this is a case where I can see that this term and this term are going to go away when I make that substitution of 0, because 0 times anything is going to be 0. So I get x squared equals 1. So x is going to be, when I take the square root, going to be plus or minus 1. So I'm going to have plus or minus 1 and 0. Okay, for the y-intercept, we're going to let x equal 0. So I'm going to have 0 squared minus 0 times y plus 3y equals 1. So this term and this term are gone. We'll get 3y equals 1. So y is going to be 1/3. So my coordinates then are going to be 0 and 1/3. So I have 2 x-intercepts and only 1 y-intercept. Okay, so on this problem, we're going to be doing some graphing by looking at it by changing the window, because what you're going to see is that this equation looks very different depending on the window that you have it on. So I want you to go ahead in your calculator and enter the equation that you see there. So in the place of y equals, I want you to enter y equals 1 divided by 1 plus x squared. So back over on the graphing calculator on the y equals screen, so go to y equals and be sure that you enter this equation here that we're working with. You want to make sure you put parentheses around it, unless you have a calculator that sets up a fraction so that it already groups the denominator together. If you have that, you probably know what I'm talking about. So we want to start out and do our standard, we want to do zoom, and we want to do number 6 for zoom standard. Okay, so when we look at this, we don't really see all the key characteristics that we would like to see. So this particular problem wanted us to change our viewing rectangle. So if we change our viewing rectangle, we're going to go to Window, and then for the X minimum, we're going to put in -5. Okay, and then on the X max, we're going to put in a +5. And then the Y minimum, we're actually told that we're going to use a -1. And then for the Y maximum, we're going to use a 2. We're going to leave everything else the same. And we're going to press graph. And you can much more clearly see the characteristics of this graph. You can see its intercept clearer and how it's behaving here around the origin. So changing the window on your calculator is very important for you to be able to do. Okay, here's one that I would like for you to enter in your calculator and change your window. So this first coordinate is your X minimum and your X maximum. And then the second coordinate is your Y minimum and your Y maximum. Okay, so on this one, you should have entered your equation like this. So x divided by x squared plus 25, and you should set your window to look like this. So you've got x min, x max, and y min and y max. And so once you've changed your window, we're ready to graph. And so you can see a very clear graph here that you would not have otherwise seen if you had used just your standard window. So sometimes you need to adjust this window in order to see a lot of the key characteristics of a particular graph. So I feel like this section has just a lot of different types of graphing and geometric shapes and so forth. So the next thing we want to look at is that of a circle and the equation of a circle. The equation of the circle is here, x minus h squared plus y minus k squared equals r squared. This is on your formula sheet, so I never really require that you memorize a lot of formulas. They're available to you on the formula sheet. So here, your h and k are going to be your center, and your radius is the r. So this is radius squared, just keep that in mind. And if you happen to be working at the origin, then this h and k are going to go away, and you'll just have x squared plus y squared equals r squared. Okay, so if we want to graph this equation here, if I look at this, this would be x minus h squared plus y minus k squared equals r squared. So in order for these parentheses to have collapsed away, that means my coordinates for the h and k would have had to be 0, 0. And then for the r, if r squared is 25, then r is going to have to be 5. Just take the square root of that number there. So it's centered here at the origin, and it has a radius of 5. So I'm going to go 5 in each direction. Okay, and then I'm going to draw in this circle, and my pen does not work great for doing this, so please understand that this is supposed to be a nice round circle. Okay, so that's the circle that is centered at the origin with a radius of 5. Okay, on this one we've got x minus h squared plus y minus k squared equals 25. Okay, so here my h is going to have to be 2. Here my h is actually going to have to be -1, and my radius again is going to be 5. Be careful about this, because basically whatever this sign is, you're going to switch it. So if this is a -2, then the h is +2. If this were a +1, then the h is -1. Because in order for this to be a positive, it would have had to been y minus a -1. So when I go to graph this, it's centered at the point 2, -1, so that's where I'm going to start. I'll go 5 in each direction from that point. And then the hardest part here is going to be connecting our points so that it actually looks like a circle. And there's our circle centered at 2, -1 with a radius of 5. Okay, we want to find an equation of the circle with a radius of 3 and a center of 2, -5. So this is going to be my h and my k and my r. So it's really just a matter of plugging it into this equation for the circle. Okay, so we'll have x minus h is 2. And then y minus k is -5. And then r is 3. So just plug everything in and then simplify. So we've got x minus 2 squared. This will be y plus 5 squared, and then this is going to be 9. So this is my equation for a circle that's centered at 2, -5, and has a radius of 3. And this is just a graph of that. Okay, here we want to find an equation of the circle that has points given as the endpoints of a diameter. So I'm going to just do a rough sketch here. I've got the point 1, 8, and then I've got the point 5, -6. Okay, so these are, I'm going to connect these in hopefully a straight line. This pen is just not great for drawing straight lines. Okay, so that's going to have to suffice for our straight line. So we want to make a circle out of this so that, I apologize, this does not look like a circle, but this is the circle with the endpoints of its diameter. So somewhere in here we've got a center that we've got to find, and we've also got to find a radius. So our center is actually going to be the midpoint of this diameter here. So if I find the midpoint, if you remember our midpoint, we find by adding the x's up and adding the y's up, divide each of those by 2. So I'm going to have, this will be 6 over 2 will be 3. This will be 2 over 2 will be 1. So I have the coordinates here, 3, 1 for my center. Okay. So in order to write the equation of a circle, I need a center and I also need a radius. So in order to find my radius, I'm going to have to find the distance between the center and the outside edge here. So this is going to be my radius that I need to find. So I'm going to use the distance formula. and I'm going to use these 2 points here. So my y2 minus, or sorry, okay, we'll get started right here. X2 minus x1 squared plus y2 minus y1 squared. So my distance then, if I go to simplify this, this is going to be 2 squared. This will be negative 7 squared. So I'm going to have 4 plus 49 is going to give me the square root of 53. And that's going to be my radius. Okay, so this distance in here is the radius. So when I go to write my equation of this circle, I'll have x minus h squared plus y minus k squared equals r squared. So I'm going to use this as my h and k back over here because that's the center of my circle. So I'll have x minus 3 squared plus y minus 1 squared equals the square root of 53 squared. So I'll have x minus 3 squared plus y minus 1 squared equals 53. So here is a much better drawing than what I was able to do for this. So we have the circle that has this diameter. We found that the center was 3, 1. And then we have to figure out what the radius is by calculating the distance between the outside edge and the center here. Another option would be to calculate the distance between the endpoints of the diameter and divide it by 2, and you should get the same answer. Okay, symmetry is the last topic that we're going to look at for today. You can have basically 3 different types of symmetry. You can have symmetry about the x-axis, symmetry about the y-axis, and symmetry about the origin. So when you look at a graph like this particular graph has symmetry about the y-axis because it means, what that means is if I took and folded it down the y-axis, it would fold over on top of itself. So the left side of the graph is a mirror image to the right side of the graph. Because of that, we see that the point xy and also the point negative xy are both on the graph when it has y-axis symmetry. Okay, so when we look at the ways that we go about doing this, I'm not going to look in detail on this screen. I'm going to kind of go on here. If we're working with symmetry with respect to the x-axis, that means if I folded it along the x-axis, it would be a mirror image onto itself. And so the y and the negative y are both going to be on that graph. And so our process we're going to use to find this is we're going to replace y with negative y and then simplify what's left. If the resulting equation is equivalent to the original equation, then it has x-axis symmetry. Moving on with respect to the y-axis, if you it's going to be a mirror image along this y-axis here, and if you replace x with negative x and simplify, then the resulting equation would be equivalent to the original equation. Next, symmetry with respect to the origin. This is more like a 180-degree spin. If you took this and spun it around the origin, it's going to end up over here. So we find this by doing 2 replacements. We replace y with negative y and x with negative x, and then we simplify, and then finally we check to see if it's equivalent to the original equation. If that's true, then it has symmetry about the origin. Okay, so let's test for some of these. You have to test each part individually. So if I'm going to check for x-axis symmetry, we said we're going to replace we're going to replace y with negative y. So I'm going to have x equals negative y squared. Simplify that, and it equaled the original. Okay, so that is a match to this, and therefore it has x-axis symmetry. If I'm going to check for y-axis symmetry, my procedure is going to be that I replace x with negative x. So that means I'll have negative x equals y squared. divide by -1, and I get x squared equals -y squared. That is not equal to this original back up here, and therefore it does not have y-axis symmetry. And then finally, the origin, I'm going to kind of come over here. The origin, we do both replacements. We replace negative x, sorry, we replace x with negative x, and we replace y with negative y. So we're going to have, again, going back to this original, we'll have negative x equals negative y squared. Simplify. So we're going to have x equals negative y squared. That does not equal what we started with. So the only type of symmetry this one had was x-axis symmetry. Here is a graph of this, and you can see that this would have x-axis symmetry, but would not have y-axis or origin symmetry. Okay, here's a couple others to practice with. If you'd like to try these by pausing it and trying it yourself, that's fine. Otherwise, I'm going to go ahead and go through this. For x-axis symmetry, we want to replace y with negative y. So I'm going to have negative y equals x to the third minus 9x. We're going to have to get rid of this negative. So I'm going to get y equals negative x plus 9x. If we compare that back around to the original here, sorry, negative x to the third plus 9x. When I compare it back around to the original, that does not match, so it's not, does not have x-axis symmetry. For y-axis symmetry, we're going to substitute in the place of x, we're going to put in negative x. So we're going to have y equals negative x to the third minus 9 times negative x. If we recall, a negative to an odd power is going to stay negative, so it simplifies, the parentheses go away and the negative comes out in front. Here, two negatives make a positive, and so this was also not equal to the original. So if we look at this, it does not match with this. And then finally, origin, we're going to do, in the place of x, we're going to put negative x. In the place of y, we're going to put negative y. We're going to simplify, much like we just did. We will need to divide by that negative 1. So we're going to get y equals x to the third minus 9x. And if I compare this back to my original, that is a match. So it does have symmetry about the origin. Okay, looking at this one, we want to check for x-axis symmetry, which means we'll put negative y in for y. We'll need to divide that negative 1 away. So we're going to get y equals negative x squared, sorry, negative x to the fourth minus x squared. And when I compare it back up here, it does not match, so it does not have that type of symmetry. For the y-axis, we're going to put in negative x. So we'll have y equals negative x to the fourth plus negative x squared. If I have a negative to an even power, then the negative is going to go away and I'm going to be left with x to the fourth. Here, a negative to another even power goes away. And because I look, and this does match with the original up here, it does have that type of symmetry. And then origin, if you put in both substitutions, negative y for y and negative x for x, simplify. So by the same process, this will be an x to the fourth and an x squared. We'll need to divide by negative 1, and so we're going to get y equals negative x to the fourth minus x squared, and that does not match with the original. So we do not have that type of symmetry. So y-axis is the only type of symmetry that this. Okay, looking at this one, we've got to check for x-axis symmetry, we're going to substitute negative y. Simplify. So we have a negative to an even power, makes that negative go away. Here, a positive times a negative keeps it a negative. When we compare that back, it does not have that type of symmetry. For y-axis, we're going to substitute negative x for x. A negative raised to an even power is positive. Here we have a negative. This one doesn't match either, so it does not have y-axis. Here we're going to make substitutions for both x and y. So negative x squared times negative y squared plus negative x times negative y equals 1. This will be x squared y squared, and this will be plus xy. So this one does have symmetry about the origin. So it is possible to have no symmetry at all, and it's possible to have all three symmetries, and you can have combinations thereof. So just kind of keep watch for that. Okay, that's the last example that I'm going to do for today. So if you have any questions, please be joining us on our Zoom sessions, asking me for time during office hours and trying to get your questions answered. Go to our SI sessions. There's lots of ways to get help with this if you're having any trouble. So please take advantage of that. One thing about online courses is you have to be a little bit more organized and motivated to get the help. The help is there. You just got to track it down a little bit. I'll be glad to help you and put you on to the right resources for you if you just let me know that you're looking. Thank you and have a good day.